Hello and welcome. In this video, we'll show you how to gather synthetic data with Simulink 3D animation. Simulation is a key part of model-based design, and using synthetic data from the simulation can help accelerate tasks like training deep learning models or validating solutions. Simulink 3D animation allows you to curate the dataset and create multiple variations of a scene in a short time. We'll walk through its photorealistic simulation capabilities, available environments, supported sensors, scene customization options, and how to extract ground truth data. To get started, open Simulink and search for Simulation 3D Scene Configuration block. Simulink 3D Animation and other add-on products offer a variety of pre-built worlds such as urban streets, highways, etc. You can see the available pre-built scenes by setting the scene source to default scenes and clicking on the drop-down menu next to scene name. Each environment comes with unique features like varying terrain and obstacles, so you can choose the best scene for your project. For example, let's choose a city block and run the simulation. You can see that the simulation world is rich with details such as lane lines and road objects. You can move around the scene by clicking and dragging with your mouse. You can also use keyboard buttons like W, A, S, and D to move forward, left, back, and right. Switching between worlds is easy. You can do that by just choosing a different world under scene name, and you can also adapt them to match your specific requirements. You can also create your own scene in Unreal Editor or import from Roadrunner. You can find the details of doing that in the video description. Now let's add an actor to this world. I'll navigate to Simulink 3D animation library and choose vehicle with ground following from the actors. When you open the block, there are several options available on the drop-down menu. Or you could also add a custom mesh if you want to import your custom vehicle model. You can set other parameters of the actors such as color, coordinate system, position, light controls, etc. For now, I'll choose an existing option, a red muscle car. To make the vehicle move, I'll add a ramp signal to X position and constant value to Y. I'll set the yaw to 0 so it moves in a straight line. Now when I run the simulation, you can see that the vehicle has been added to the scene and it is moving in a straight line as expected. To gather data similar to real sensor outputs, start with a parameterized sensor model. Simulink 3D animation offers various options including cameras, LiDAR, radar, and ultrasonic sensor. For example, I'll add a camera and specify its parameters. I can add mounting details such as location, parent actor, and coordinate system. Here, it automatically takes the vehicle as the parent actor as there is only one actor present. I'll choose the front bumper as the mounting location. If you know the precise spot for the camera, you can set an offset. The parameter tab allows you to adjust settings like focal length, image size, and distortion coefficients to match your actual camera. You can find your camera's parameters by using the camera calibration app, which is linked in the description. Next, I'll add a video viewer to the camera and run the simulation. Here, you can see the scene as well as the camera output. You can follow the same steps for other sensors. For instance, I'll stop the simulation and add a LiDAR to the car by dragging its block from the library, selecting the mounting point, and attaching a point cloud viewer to view the output. Running the simulation, you can see the output of the camera and the LiDAR sensor. Sensor parameters are fully customizable, so you can fine-tune them to replicate your specific hardware. Integrating these sensors into your simulation is straightforward, and the output can be monitored in real time as your robot or vehicle navigates the environment. Now we have sensor data, but to train or validate our model, we need matching ground truth data. Labeling is a time-consuming process, but the sensor block also outputs ground truth data. For example, open the camera block and click on the ground truth tab. You can select output semantic segmentation to get labeled data. With semantic segmentation, each fit cell is labeled according to the object it falls into, and each object has a specific ID. I'm using a simple script to convert these labels into different colors to see the semantic output. Now let's add a video viewer to the semantic output data and run the simulation. You can see the camera output and ground truth semantic data from the simulation. You can save this data by using a 2 multimedia file in Simulink. Having this ground truth data speeds up your development process and improves model accuracy. We now have some data from ideal conditions, but to build robust solutions, we need data from varying conditions and test our models in them. With Simulink 3D animation, you can change lightings and adjust weather parameters like fog, rain, and snow. Open the Simulation 3D Scene Configuration block and click on the Weather tab. Select Override Scene Weather and adjust the weather as required. Here, I'll add some rain and make it a bit cloudier. I'll also make sure raindrops stay on the camera lens to mimic real-world conditions. Additionally, you can also customize lights for indoor environments, and you can find that information in the description. Now let's run the simulation again to see how it looks. And as you can see, in a few quick steps, we were able to collect sensor data from 2 different conditions. If you want to further customize the scene, like adding new custom objects or modifying layouts or building a completely new scene to reflect your use case, check out the linked resources in the video description. Thank you for watching.